We've been talking about ways to factor, which is what we are doing when we're trying to find the x-intercepts of a polynomial function. So we've been practicing long division and synthetic division. And yesterday we started getting asked questions like, look at this polynomial function. I think these two are factors, so try them and then find the other ones. Well, in a real problem, they're not going to give you any of the factors. You're going to have to find them all. And so when that's the case, how do you know what to try as an x-intercept? In other words, what am I going to put in my little box for synthetic division? Because I could plug in anything I wanted to. Well, they have what's called a rational zero test. It's a way to list all rational numbers whose numerators are factors of the constant term and whose denominators are factors of the leading coefficient. This is a list of all possible rational zeros. So, just to give you an idea, if I had something that looked like, and I'm just making this up, 3x to the fifth minus 4x squared plus 2x minus 11. Let's do something besides 11. 8. Okay? To list all possible rational zeros, we're going to find all of the factors of the constant term. That's the term at the end. So what are the factors of 8? Well, 1 times 8, 2 times 4. So the factors of the constant term would be 1, 2, 4, and 8. Then the denominator, factors of the leading coefficient, that's going to be what all multiplies together to give me 3. That would just be 1 and 3. So all possible rational x-intercepts are at 1 over 1, 2 over 1, 4 over 1, 8 over 1, 1 over 3, 2 over 3, 4 over 3, and 8 over 3. I'm just listing out all possibilities, the factors of the constant term in the numerator, the factors of the leading coefficient in the denominator. So I wrote all of these over 1, then I wrote all of these over 3. These are the things we want to try in our box. Now the other thing we have to remember is that these can all be plus or minus. So we've got 16 different things to try in our box. Which one do you want to try first? Probably not the fractions, right? I would probably choose these whole numbers because they're a little bit easier to work with. But we don't know what will work, but here's a list of things to try. It's better than just trying completely blind, not having any idea what to pick. So now we're narrowing down our possibilities. When we form this list of possible rational zeros, we're going to use trial and error method to determine which, if any, are actual zeros of the polynomial. Note that when the leading coefficient is 1, the possible rational zeros are simply the factors of the constant term. So what they're saying is if my leading coefficient here is 1, well then I'm just going to put all these over 1, and that's my only possibilities for a rational zero. So just to review, what is a rational number?
Number that doesn't end in infinite decimal points.
Correct. Rational numbers are numbers that can be written as a ratio of two whole numbers. So a fraction, like this. So we can have x-intercepts that are not rational. And so things that would not be rational, our x-intercepts could be like 1 plus radical 5. Okay, this would not be a rational number because the square root of 5 is not a rational number. So things like this, the only way to find those as x-intercepts is to factor. But these we can find as x-intercepts by using the rational zero test. So they're going to start us relatively easy. They want us to find all the rational zeros of f of x equals x cubed plus x plus 1. So the first thing I want to do is list all the possible rational roots from this equation. So what are all the factors of the constant term? 1. All the factors of the leading coefficient? 1. So the only thing I have to try is plus or minus 1. That's my only list. So they've narrowed it down for us to make it pretty simple here. Okay, so I would try positive one first. No particular reason, I just would. So when I list my coefficients, I've got my x to the third, x to the second is 0. Don't forget the placeholder. X to the first, and my constant. When I bring 1 down, 1 times 1 is 1, combine 1. 1 combine 2. 2 combine 3. So I got a remainder of 3. So is 1 a rational 0?
No.
It is not, because I got a remainder of 3. That means 1 did not work. So I'm going to erase and try again. The only other thing I have to try is negative 1. So I bring down the 1. 1 times negative 1 is negative 1. Combine, multiply, combine, multiply, combine. So is negative 1 a rational root? It's not either. So that means this problem has no rational roots. Okay, but I know it still has an x-intercept somewhere. Because, think about it, x to the third has disagreeing in behavior. And because it's positive, it's going to be increasing. So there's an x-intercept somewhere, but where it crosses is not a rational number. So let's look at the graph. So the way that we could find this graph, the only way is to use the graphing calculator. It says here, you can conclude the polynomial has no rational zeros. Note that from the graph of f shown below, f does have one real zero, and it's somewhere between -1 and 0. Right? I don't know what it is, but I know it's between there. But just using the rational zero test, we know that this is a real 0, which means it exists. It's a real number, but it's not a rational number. So again, can't find what it is yet, but I'm just letting you know it exists. Just because we don't find them doesn't mean there aren't any. It just means it's not rational. I can't write it as a fraction. I'm going to do this one with you because I really don't like that example. Okay? Find the rational zeros of f of x equals x cubed minus 5x squared plus 2x plus 8. So my list of possible rational zeros. What are my factors of 8? 1 and 8, 2 and 4. My factors of 1 are 1. So the only possible rational roots are 1 over 1, 2 over 1, 4 over 1, and 8 over 1, plus or minus all of those. So then to find which ones actually work, it's just trial and error. So I would start with 1, just because it's the easiest one. I've got 1, -5, 2, and 8. I'm going to bring down the 1. And then do the synthetic division. Okay, so 1 did not work because I got a remainder of 6. So I know 1's out, so I'm going to try a different number. So like I said, you can go somewhere else. I'm just going to erase because I don't have a lot of room on here. So the next thing I'm going to try, again, there's no rhyme or reason. I typically like to keep trying positive numbers just because I do a little bit better for the synthetic. I don't have as many opportunities to mess up. And then we multiply. Okay, so now then I have used 2 as a rational root, and it worked because I got a remainder of 0. So that means I know 2 is an x-intercept. I found one of them. So now what I have left is a depressed polynomial, which is x squared minus 3x minus 4. You can do this again. You can continue this whole process of trial and error. So now then, with the new depressed polynomial, what are the possibilities? Only 1, 2, and 4 now, right? 8 is gone because they aren't, I can't get 8 because it's 4 at the end. But I typically don't want to keep doing trial and error. That is something you can do. You can keep trying them. But once I get down to a quadratic, I'm factoring. X squared minus 3x minus 4. So what multiplies to be negative 4, added or subtracted, is negative 3. That would be a negative 4x and a positive 1x if you need to do the A times C method. All right, and I'll let you continue doing that one. I can see just by looking, it's x minus 4 times x plus 1. Which means my other x-intercepts are at 4 and at negative 1. So when it asks me to find all the rational zeros, negative 1, 2, and 4 are my 3 rational zeros. Now I know if I found more than that, I would be wrong again. Because this is a third degree polynomial, it can't have more than 3 x-intercepts. Well, because I'm finding x-intercepts, I'm finding where the y value is 0, right? So I'm looking where 0 is equal to x cubed minus 1/9 x squared minus 4x plus 4/9. Well, yes, that would be the first thing I would have thought of. I would have multiplied everything by 9, and that would get rid of my fractions. So if you want to do that, that's 9x cubed minus 1x squared minus 4x. Sorry, this shouldn't be a 4x. That should be a 36x plus 4. And now then your list of possible rational zeros is going to be much easier to deal with. All right, so has anybody found any that works? Two? Yep, 2 worked. So that left me with 9x squared plus 17x minus 2. And so now if this were me, I would factor that. So A times C is 18. What multiplies to be 18 added or subtracted is 17? 1 and 18. So I'm going to rewrite this as a positive 18x minus 1x. Then when I GCF, I've got 9x times x plus 2, and then negative 1 times x plus 2, which means I'm left with 9x minus 1 times x plus 2. So 9x equals 1, x equals negative 2, x equals 1/9. So I've got 1/9, negative 2, and positive 2 are my x-intercepts. Now, when you did your trial and error, you may not have found 2 works first, right? You could have found negative 2 worked first. Or you could have found 1/9 worked first, which I don't know why anybody would be picking fractions first, but to each their own. For me, though, when I looked at the original, and even once I got to here, I'm pretty sure that we could have factored this. I would have never even had to do trial and error. So when I see 4 terms, what do I try to do to factor? I'm going to factor by grouping. So GCF would have been x squared. That leaves me with 9x minus 1. GCF here is negative 4. That leaves me with 9x minus 1. So the parentheses matched. So I could have written this as x squared minus 4 times 9x minus 1 equals 0. Then we said each one of these equal to 0. So that would be x squared minus 4 equals 0. 9x minus 1 equals 0. So this tells me x squared equals 4. This tells me 9x equals 1. And then when I simplify again, I'm taking a square root, so that's plus or minus 2. I'm dividing by 9. So I found 3 x-intercepts of positive 2, negative 2, and 1/9. So this one had a way to find the x-intercepts by factoring. I didn't even have to use the synthetic division for trial and error. But again, you can do it the synthetic division. You can look to factor. When I factored at the end and did a times c, you don't have to do that. You could have plugged this into the quadratic formula. Right, your 9x squared plus 17x minus 2. That would have given you 2 x-intercepts that are 1/9 and negative 2. Or if you see you can factor at the very beginning, you can factor. So right here it tells me to find the rational zeros of f of x equals 2x cubed plus 3x squared minus 8x plus 3. I don't think you're that far off. Okay, so now I'm going to list what are my possible rational zeros. The factors of the constant term, which are 1 and 3, over the factors of my leading coefficient, which is 1 and 2. So my possible rational roots are at plus or minus 1 over 1, 3 over 1, 1 over 2, 3 over 2. So those are the 8 things that I would try in my synthetic division. So when I look at my original, that will not factor by grouping. So I know factoring is out. So the only thing I have that will work is synthetic division. So I'm going to start with a 1 because why not? So I've got 2, 3, negative 8, and 3. I bring down the 2. Hey! 1 worked. And so I have found my first x-intercept. It's at 1. And now I'm left with 2x squared plus 5x minus 3. So I would factor to find the remaining ones. So a times c is 6. What multiplies to be 6, added or subtracted, is 5. Well, it could be 2 and 3, or it could be 6 and 1. How do I know which one to choose? Well, I need them to multiply to be negative. So that means I need them to be opposite sign. So how can I combine to get 5 with opposite signs? 6 and 1. I need 6 to be positive, 1 to be negative. And that will give me the positive 5x in the middle. So I'm going to rewrite this as 2x squared plus 6x minus 1x minus 3. GCS, 2x, x plus 3, GCF negative 1, x plus 3, parentheses matched. It's good news. So now I've got 2x minus 1 times x plus 3. So I'm looking at 2x equals 1 and x equals negative 3. This will give me x equals 1/2. So my rational roots are at 1/2, negative 3, and 1. So right here, the list of all possible rational zeros would be plus or minus 1 over 1, 2 over 1, 3 over 1, 5 over 1, 6 over 1, 10 over 1, 15 over 1, 30 over 1, 1 over 2, 2 over 2, which I already have listed as 1, 3 over 2, 5 over 2, 6 over 2, which I already have listed as 3, 10 over 2, which I already have listed as 5, 15 over 2, and 30 over 2, which I already have listed as 15. So I've only got 1, 2, 3, 4, 5, 6, 7, 8, 9. I've only got 24 things to try. So not too bad.
2 works.
2 works? Did you guys try 1? 1 didn't work? Okay, 2. So I'll write down my coefficients. 2, negative 9, negative 18, 71, and negative 30. Hey, it did work. Looks like a fish, not a 0. That's a little bit better. Okay, so 2 is a rational 0. Then what I have left, 2x cubed minus 5x squared minus 28x plus 15. So it's not a quadratic, so I'm not guaranteed to factor. So I'm looking, do I have a GCF? Like, can I factor by grouping? No. And no. So grouping won't work here either. So I'm going to have to do synthetic again with my new depressed polynomial. But it helps me narrow down my list of possible rational roots. So the new thing I'm doing synthetic division on will be 2, negative 5, negative 28, and 15. So now think about it. It has to be a factor of 15. So that means some of the things that were factors of 30 are out. 15 is just 1 and 15, 3 and 5. And then that can be over 1 or over 2. Right? So I'm going to try all the things over 1 first. If 1 didn't work originally, 1's not going to work now. So I'm not even going to try 1. The next thing I would try would be 3. Has anybody tried 3 yet? On the depressed one, did 3 work? No. Okay, did you try 5? Did 5 work? 5 works, okay? So let's try 5 for my new depressed polynomial. So 5 goes in the box. It's going to be 2, 10, 5, 25, negative 3, negative 15, 0. Yes, it did. So 5 worked. So now I found 2 x-intercepts so far. I found 2, and I found 5, and now I have a quadratic left. So I know I can either factor or use the quadratic formula. I'm always going to try to factor first, because to me it's quicker, simpler. So if I do a times c, I get 6. This looks very similar to the last time, right? Multiply to be 6, combine to be 5, but I need them to be opposite sign. So it's going to be positive 6 and a negative 1. So that's going to be 2x squared plus 6x minus 1x minus 3, which is going to give me 2x times x plus 3, negative 1 times x plus 3, which is 2x minus 1 times x plus 3, which is going to give me intercepts at 1/2 and at negative 3. So my 4x intercepts are negative 3, 1/2, 5, and 2. So if I had to graph this, I know my x-intercepts are at 2, 5, 1/2. That's the whole point. We're learning all these tools to be able to find the x-intercepts. That's the whole purpose of what we're doing. This is just how to find the x-intercepts. So when we look at this, we should know the end behavior, 4th degree, so it agrees. Leading coefficient is positive, so it's up in both directions. I should also know that there can be 3 turning points. There could be no more than 4 x-intercepts. Well, I already found those. The x-intercepts were at -3, 1/2, 2, and 5. We can find the y-intercept. The y-intercept is at -30. It's always the constant because you're plugging in 0 for x. 0, 0, 0, 0. All these are gone, so the y-intercept is -30. And now the other thing we can look at is multiplicity. So every one of these x-intercepts only happened one time. So that means the graph is going to cross every one of these x-intercepts. So when I take all that information and graph it, okay, so I know because of my end behavior, the graph's going to start up here. It's going to end up here. It's got to cross at -3. It's got to cross at 1/2. It's got to cross at 2. It's got to cross at 5. And it has to have an y-intercept that's at -30. So that's going to be way off my graph. Right? So way down here. -30. That's not even close, but I'm still just going to go with it. So I'm here. The y-intercept is -30. Then it has to come back up in time to get to 1/2. And then it's got to swap, go back through 2, swap, go back through 5. The graph is going to look something like this. Is that exact? No. But I'm getting key features. Look at the turning points. It turned 1, 2, 3 times. Can't turn more than that. I don't know where these turning points happen, though, because, again, you're not going to know that until you have calculus tools to help us. But for now, that's as close to a sketch of the graph as I can get. What are the possibilities? Plus or minus 1, 2, and 4. Right? So, I would start with trying 1. So it's going to be 1, 4, 3, -4, -4. Bring down the 1. 1 times 1 is 1. 5, 5, 8, 8, 4, 4, 0. So that means 1 works. And now my new depressed polynomial is an x cubed term. So I still have to do synthetic again. I could try 1 again, but I know 1's not going to work. So I'm going to try -1. Actually, let's just do this. Let's try -2. Okay, and that's going to give me 1, 5, 8, 4. That's going to be 1, -2, 3, -6, 2, -4, 0. So -2 works. And now what I have left is x squared plus 3x plus 2. Right, from here. Now then, if I factor that, multiplies to be 2, add or subtract is 3. So you can do a times c, or I can look at this and know that this is x plus 2 times x plus 1. So I have x-intercepts at -2 and at -1. So my x-intercepts are -2, -2, -1, and 1. So in this case, -2 would have a multiplicity of 2 because I found -2 twice. So if I graph that, again, just very general, I'm going to have x-intercepts at -2, -1, and 1. I know the y-intercept is at -4. I know because I had a positive leading coefficient, the end behavior is going to look like this. Up on both ends. Now, my x-intercept at -2 had a multiplicity of 2. So that tells me that the graph is going to bounce off -2. So we're going to bounce up Then we're going to cross, -4, boom, and then cross at 1, because those only had a multiplicity of 1. And again, not exact, but I've got all the key features. I know it bounces, crosses, 3, up. I got the correct indicator. 3, if I had a multiplicity of 3, it's going to snake through it. 4 bounces. 5 snakes, 6 bounces. Every even bounces. The odds, 1 crosses like a line, 3, 5, 7 snakes.
So if it was -3 out there, you could.
I'm talking about multiplicity. How many times the x-intercept occurs?
Oh, okay, so since -2, since there are 2 bounces.
Yes.
Okay.
If it occurred 3 times, it would snake. If it occurred 4 bounces, 5 snake.
This is very easy in the section.
You like it? Does
Easy.
that mean you like it?